This is the warm-up for Secondary 1 Math, lesson number 6-5. Okay, for 6-5, first of all, we are going to describe the pattern and determine the next three numbers in the list. So we are looking at the pattern here, and I see 1, 3, 5, 7. So that's a familiar pattern. We know that those are all of our odd numbers. And so we are going to tell what happens. So we can first say, well, what's going to keep happening? So the next three numbers are 9, 11, and 13. And then what's happening is I'm adding 2 each time. Okay, for number 2, I go from 7 to 4. So think about how you get there. I would subtract 3. 4 minus 3 is 1. 1 minus 3. And so it looks like I'm subtracting 3 each time. And then so if I keep going, I have negative 8, negative 11, and negative 14. For number 3, I have 0.5 and then 1. So that's a half and then a whole. And so how do you get that? Well, you take 2 halves, so you're multiplying by 2. Sometimes that might not be as obvious, but if you look at 1 to 2, you're multiplying by 2, or 2 to 4, you're multiplying by 2. So that's my description, is I'm multiplying by 2. And so if I keep doing that, 8 times 2 is 16, times 2 is 32, and times 2 is 64. Okay, number 4, 243, 81, 27, and 9. If you're not really sure, you could look at these numbers. Those should be more familiar because of times tables. So you're actually dividing by 3. And we're going to come back and say that a different way in just a second, because there's another way that you can describe that as well. But then the next three numbers will be 3, and then 1, and then 1/3. So I'm just dividing by 3. So on number 2 and number 4, I can actually describe those in different ways. Another way I can say number 2 is I can say, instead of subtracting 3, I can say I'm adding a negative 3. And that's going to come back to be important later on. And on number 4, another way I can say, instead of dividing by 3, I can say that I'm multiplying by 1/3. That's the same as dividing by 3. So write both of those down. Okay, numbers 5 and 6, it says, given a mapping diagram, write the ordered pairs that represent the relation. And so we are missing the arrows there. We are going to write the ordered pairs. So negative 3 goes with 0, and 0 goes with 2, and 4 goes with negative 7, and 11 goes with negative 1, and 16 goes with 2. And that's my relation. Number 6, same thing. We're going to say negative 5 goes with negative 4, negative 2 goes with 8, 1 goes with 10, 1 also goes with 12, so that right there makes it not a function, by the way, and 6 goes with 1. So number 7, it says, is the relation number 5 a function? Well, if we look at all of our domain, we don't see any duplicates. We don't see anything here where we had one of those trying to go more than one direction. So this one is a function, and because the domain does not repeat. Okay, number 8, it says, is the relation number 6 a function? And we saw right here that that is not a function because of that right there. So that's going to be no, and that's because the domain repeats.